Okay, I'm going to be working out a problem that the students were doing here in class with me today. They were supposed to do odds or evens on the problems. This is already on Moodle. And we're just going to show how we did the problem in class. Okay, first thing that we do is we figure out what the problem is, and if we look at what they're asking us here, if we look at the table, we should be able to see that they're talking about trials and the number of bugs dead. So then we can kind of infer based on this data that A, the problem was do expensive bug repellents kill more bugs. Okay, and again, the cause and effect, we do a problem and we write it in cause and effect form. Okay, again, what is the cause? The expensive bug repellent. This is what we call a cause. And then students don't have to write that. I was just showing to them how they're supposed to be writing it, but they don't actually have to label cause and effect. And then we have the effect here, kill one of the bugs. So this will be our effect. And problem statements are written like that in the form of a question. I'm going to try to make it a little bit smaller, but B would be, oops, B is we make a hypothesis statement. So all we do is we take our problem statement and we turn it into into just a regular statement in cause and effect. So expensive bug repellent brands will kill, oops, kill more bugs. Okay, and again, this is going to be our cause. We have a cause here, the expensive bug repellents, and the effect that we think it's going to have is going to kill more bugs. Okay. Now, unfortunately, I'm going to have to erase some of this so that I can go over the other ones, the other answers. So I'm just going to have to erase this to make some room. I'm going to go to C now. Okay, dependent variable. C. The dependent variable. The dependent variable is what we measure. So here, we're going to be measuring, the number of bugs dead. So the number of bugs dead is our dependent variable. Okay. For D, the independent variable is what we change. So in this case, we're going to change the type of repellent. Okay. Now in E, our control group is going to be what normally occurs, or what's not being changed, which in this case, it'll be the bugs not sprayed, or the no repellent. Okay. Then on F, we're asking for the experimental group. And of course, that's going to be the other brand. So the experimental group will be the bug sprayed with repellent. Okay, now I'm going to erase this so that I can do, oh, G's easy. G is what type of graph should be used. Okay, this one you can either go with a line or a bar graph, and it'll work. Okay. And just because it's small enough trials and there's several things that we're comparing, so either one of those would be correct. Okay, now I'm going to have to erase that so I can do the graphing part. But you can always rewind to go back to those parts. Okay, now the graphing part, it asks us on H, what would be plotted on the x-axis? And in science, without fail, it will always be this way. Trials is always going to be my x-axis, and it's my independent variable though, because it's the times I use the bug repellent. Okay, so that's why it's our independent variable there. Okay, now always in science, whatever is to the right of the first column is going to be our dependent variable, because this is what we measure. Okay, so this one, let me just try to see if I can do this neater. Okay, the first column is always going to be our x. It's going to be plotted on the x. And it's our independent variable because the times we use bug repellent. Okay? Now to do our graph, once we know that, what goes on x and y, then all we have to do is set up our graph here. And graphs, especially line and bar graphs, have a title, a key if they're comparing more than one thing. They have labeled axes. Here, trials will be our x, and our y is going to be the number of bugs dead. Okay. Then our scale here on our axes have to be in the correct intervals or even intervals. So in this case, we look at the biggest number that we have here on x, which is 4, so we'll make this 5. And the space that we use in the x has to be used in the y, so if we have to extend, we'll extend. Oops. We'll extend the line so that we can be able to see things better. But this is going to be the y. And we have to use the same amount of space for both of them. Okay? So then I look at my biggest number is 4, so then I used 5 here on the x-axis, so I'll just divide it evenly. 4, 3, 2, 1, and of course that's 0. And then over here, I look at the biggest number on the dependent variable, and my biggest number is 14, so I'm going to go 1 up higher, which is 15. And I'll go by 5s, 5, 10, 15. So even multiples are the same. I go by 5s, I go by 2s. It just makes sure, I need to make sure that I'm using the right intervals. And then all I got to do is plot my information here. So blue, I'm going to use, okay, for trial 1, no repellent on 1, it was 5. And I'm going to make this no repellent, which is our control. Okay, so, and then on 2, trial 2, we had 1. On trial 3, we had 5. On trial 4, we had 1. And then we just connect dots in order. Trial 1, trial 2, trial 3, trial 4. Oops, there we go. Okay, so that line represents no repellent. And then we're going to do the RAID. And in RAID, we're going to use squares. Okay, so on trial 1 in RAID, I got 8. On trial 2, I got 11. On trial 3, I got 8. On trial 4, I got 9. And then I just connect the dots. Oops, I think that was a little bit higher. And we'll connect the dots in order. 1, 2, 3. And then we'll finish the last one. It should be pretty easy. We're just going to do 5 for generic. Okay, the trial 1 for the generic, it was 5. I'm going to use a triangle. Oh, I forgot to put RAID. Okay, and on trial 2 for the generic, it was 14. Okay, and trial 3, it was 3. And trial 4, it was 2. We connect the dots. Oops, connect the dots. And we give it title. Okay, where we have to put the name here, it's going to be generic. We put our title, and our title is, which I didn't give, oops. It just has to reflect what we're measuring. So, bugs dead versus repellent. And that's all I have to do. Odds or evens.